So this is an exercise which is related to halogen alkanes. In the first one, complete the reaction scheme to show the mechanism of a reaction for a 1-bromobutane with OH to produce R and include all necessary charge in the dipoles and curly arrow in to show the structure of R. So whenever like when we divide like make a dipole, the one which is having more which is more electronegative will have a partial positive and the other will have a partial negative charge on it. All these exercises are available on the drive in the answer key as well. So you can practice this classified one as well as you can also do the past paper directly, starting all the past paper together. But we will start from next week, we'll start the past paper discussion as well. So if you want to show, because bromine is more like a greater electronegativity, so this will be partial negative and the carbon will be partial positive. Then the OH will have a lone pair, and what it will do, it will attack on the carbon partial positive. It is, and what kind of reaction will happen here? How to know? It will be SN reaction because it's a halogen, but whether it is SN1 or SN2, so which one it will be? It will be SN2. Why? Because you can see a carbon which is bonded with a halogen, it is having only one carbon chain. So if it is having only one carbon chain, there will be SN2 reaction. So what happened in SN2 reaction? First, we'll have this a bond breaking and a bond forming will take place at the same time. One side the bond will break and another side the bond will form. So if you represent, like this is our carbon, the central carbon, a bromine is breaking the bond, the OH is forming the bond. There is CH2, CH2, CH3 is there, and there's hydrogen and hydrogen. And the net charge, what will the net charge in this transition state? The net charge on the transition state, if SN1 would show the carbon cation, then the product. Yes, that's right. If it was SN1, then I will first show a carbon cation and then the OH will attack on the carbon cation to form a product. There will be a negative charge here. The bond breaking and bond forming will take place at the same time, and then final product will have CH2, CH2, CH3, and there will be OH here. This will be H, this will be H. And we'll have Br with a negative charge is released. Next is but1-ene react with steam as shown to form a mixture of the two structural isomers S and T. So one is a major product, another one is a minor product. What will the major product? Remember, hydrogen added towards the site where already hydrogen are more, that will be a major product. What do they mean? Like out of screen? No, into the screen, or because it's a 3D structure. When you have a 3D structure, you represent a 3D structure with a wedge and the dash. So when carbon is forming a bond, it is forming one of them is into the screen, another one is out of the screen, and two of them are in the same screen, same plane. Like it's a 3D model. Carbon form 3D model structure when it is forming four different bonds. So if we have a but2-ene, which is but1-ene, I mean CH2, CH will be there. Then it will be CH2 and CH3. When it react with steam, So when hydrogen, the double bond will break, what is the one possibility? As the one of the possibilities like CH2, OH will might be attached to the first one, and hydrogen attached to a carbon which is already having more hydrogen. So this will have three hydrogen, this will be CH, this will be CH2, and this will be CH3. So this will be the major product. And what about the minor product? The hydrogen added to the one which is having less hydrogen. So this will become CH2, CH2, CH3, and the OH will be attached here. So butane 2-ol will be the major product and a butane 1-ol will be the minor product. And the reason remain the same because when the carbon cation is formed, a carbon cation surrounded by more alkyl groups is more stable. Like the tertiary carbon cation is more stable. And if we do a further reflux condenser, it's a secondary alcohol. The secondary alcohol will turn into what? It will turn into a ketone, which is butane 2-on. That's so U is actually butane 2-on, S is actually butane 2-ol, and T is butane 1-ol. So S can be oxidized with acidified potassium chromate to form compound U. S and U both react with alkaline aqueous iodine. So S and U are both reacting with alkaline iodine. What does give an indication? It gives an indication. So the carbon which is attached with OH or a carbon which is attached with a carbonyl group, there's a methyl group next to that. That's why, because as you can see, this carbon is attached to OH. This carbon is attached to OH. There's a methyl group here. This carbon is the carbonyl group. Next to there is a methyl. That's why they are reacting with acid potassium dichromate. I mean alkaline aqueous iodine. Identify the type of a reaction that occur when a butanene react with the steam. So what we call this type of a reaction when alkene is there, it's reacting with steam. So it is electrophilic. Actually, it's an electrophilic addition reaction. Addition is the main thing because it's a type. But in complete, we can say it is electrophilic. It is electrophilic addition reaction. State what can be deduced about the structure of S from its reaction with alkaline aqueous iodine. No, it's about when alkene react with steam, it's electrophilic because how the electrophilic reaction happen? There's a carbon-carbon double bond is there. There is H and OH. This will be partial negative. This will be partial positive. So this will try to form a bond here. Then OH will break the bond. So this is the electrophile which will attack. So that's why it is electrophilic addition. Why addition? Because only one product is there. If it was a halogen alkane, then it will be a substitution. So what we can deduce that anything which is in alkaline iodine, it's reacting. So we can say that there's a methyl group is attached. So it gives an idea that must be a methyl group next to a carbon with the OH. Explain why S is a major product for this reaction in butanene with steam. So why S is a major product? Because this was butanene was there, CH2 double bond C, H, then single bond CH2 and then CH3. When the attacking nucleophile, the hydrogen is there. So in this case, this will be partial negative, the OH, and hydrogen partial positive. It will attack on the double bond and OH will break the bond. So the major product is like CH2, like hydrogen is added here, then CH, then CH2, CH3. So you can see this carbon cation, like this is a carbon cation with this form. This carbon cation is surrounded by more alkyl group, like it is a secondary carbon cation, and the secondary carbon cation is more stable because the alkyl groups are electron releasing group. Like they push their electron towards the carbon As a result, the net positive charge on the carbon cation will decrease. So how you structure your answer, you will mention because like alkyl, it will form a carbon cation, which is a secondary carbon cation, and as a result, the alkyl groups, which are electron releasing group, or you can also say they have a positive inductive effect of more alkyl groups is there, as they have a tendency to donate their electron density, which reduces the net charge on the carbon cation and make it more stable. The next is draw the skeletal. So if they mention a skeletal formula, you have to draw a skeletal formula. Like you cannot draw this plate. For S is butane 2-ol. So 1, 2, 3, 4, and then OH is there. So this is S. What about T? T was a minor product, so it was butane 1-ol. And what about U? U was oxidation, so it was a ketone, butane 2-on. So these are the skeletal formulas of these compounds. You can just draw this line as well. Write an equation to represent the oxidation of S to U by acidified dichromate. Whenever you should use like the symbol to represent the oxidizing agent. So it is actually what it is, butane 2-ol. So, but the formula remains the same, butane 2-ol. But means 4 carbon. So C4H9 and OH will be there. And as a result, the product of oxidation means addition of oxygen. So butanol will turn into butanoic acid. Sorry, the oxidation of that was a secondary alcohol. So secondary alcohol, I should make a ketone. So I can draw, just we need the equation. So it will become oxidation is there. I can write in terms of the formula like C4H9OH is there. Or I can also represent in this manner. So this will become 1, 2, 3, 4 will be there. And how many hydrogen it will have about, because it's an oxidation. So C4H8 and O will be there. Because the term oxidation is having two meaning. Oxidation is addition of oxygen or removal of hydrogen. Two hydrogen will be removed here as this was a compound. This was the original compound. So the two hydrogen which will be lost, this one of the hydrogen will be lost and this is another hydrogen. And we have oxygen from the oxidizing agent. So the product CH3 was there, then C double bonded with O, CH2, and then CH3. Plus, because these two hydrogen are removed and one oxygen is there, so what is another product? So it will be H2O. So we'll have H2O as another product. This is the oxidation of a secondary alcohol, which leads to a formation of a ketone. So this was about the question. Next is another question from the topic. Any question or doubt related to the session today? So next week we will start the past papers. Next week we'll do the past paper for the full past paper. Like we'll try to discuss maximum, and even in the pop quizzes now, I'll give you the past papers to do the pop quizzes. So separate will be there for Edexcel and a Cambridge. And the same past paper we'll discuss in the class. So you can ask your doubts during a session.